We have to take up exercise 6.5, children. And now for this exercise, children, there will be a variety of questions. And if you've already gone through solved examples, read through whatever I asked you to, you must have observed there are variety of ways to deal with the question. There are so many tricks and techniques for solving the question. So here, according to the question, you'll have to decide what kind of approach you should apply to solve any particular question. So from question to question, your methods will vary. Okay, so this is what another thing you have to learn, to observe what kind of expression is given to you and which approach will be more suitable and helpful to solve it. Okay, and there one question can be solved by so many techniques. It is for you to see now which one is suiting best in where. Okay, so if I start with question number 1 here, question says find the maximum and minimum values, if any, for the following functions given by this. So this if any is written here, children. Okay, so it's not necessary that every time every function will have necessarily a maximum as well as minimum value. At times it might not have a maxima or minima, or it might have maximum value but not minimum. It might have minimum but not maximum. Okay, so we've done first derivative test, second derivative test, so many tests that to help us identify whether it is maxima or minima, and what will be maximum value and what will be minimum value. But look at these questions. These questions, we'll do them more analytically than doing it mathematically, applying those results. These can easily be obtained, understood analytically. Okay, kind of expression they are. So like the first one here is fx is 2x minus 1 whole square plus 3. So if I have to find its maximum or minimum value, what we can analyze or study this question as is, see, this out here is a square quantity, children, and we know squares are always positive. So we would say this expression given, that is 2x minus 1 whole square, being a square, we know will always be greater than equal to 0. Whatever be the value of x, it has to be positive. We know that. But in our function along with this was plus 3, so we were adding 3 both the sides. Okay, so this is what is my function now. So the value of the function then we observe would be always greater than 3. If this is always greater than 0, so 0 में आप कुछ add कर रहे हो, 3 तो add कर ही रहे हो. Okay, तो minimum value इसकी 0 है, तो plus 3 इस पूरे function की minimum value हो जाएगी 3. Okay, so we would say what are we observing from here? We are saying this given function is always greater than or equal to 3. Okay, so the value can be greater but nothing less than this. So what is this? This is supposed to be the lower limit, minimum value. So we will say maximum, it will go up to infinity. It will go on increasing. If you go on increasing x, the value of this expression goes on increasing. So we conclude that this will have no maximum value, but its minimum value would be 3. Is it clear? So that is how we are going to observe this without applying any of the results that we have studied. Just by looking at the expression we will guess. Okay. Now the second expression given to you here is 9x square plus 12x plus 2. So in this also, what are we trying to do is we are trying to introduce a whole square if possible to be able to analyze it. Okay. So as we saw 9x square, yes, it is 3x whole square, perfect square. And then this product term, remember completing the square you've done in 10th also. Okay, so to match up with your identity, a square plus 2ab plus b square, we are tallying this with 2ab. So a 2a from here we have guessed as 3x, and then we have to think what is a b. So it was 12. So 3 to the 6 we have already got. So 6, 2 is missing to make it 12. So this 12x can be split as 2 into 3x into 2. So this is our 2a, this should be our b. Then we should have a b square, so that this whole together can be written as a plus b whole square. Remember, that's just a revision of what you've already learned in class 10. Okay, now but if you've added this 2 square on your own, which we have to match up with the identity, so you will also subtract that. So we have minus 2 square as well for balancing. Okay, and then this plus 2 was already there, right? So this whole becomes 3x plus 2 whole square, and minus 4, this will become minus 4 plus 2 gives you minus 2. Right. So this given expression in the changed form is equivalent to this. Now why did we write this like this? Because again, seeing this as a whole square, we can give this argument that this being a whole square has to be always greater than equal to 0. Then to match up with the function, you will minus 2 both the sides of the inequality. Inequalities you've done last year. Okay, we can do same operations on either side of inequality. So this given function, this expression matches up with whatever the function was. This given function will always be greater than equal to minus 2. Okay, so same way in the previous case, the maximum value will go on increasing. As you keep increasing your x, your maximum will keep exceeding, and but the smallest value possible is minus 2. So we will say this function has minimum value, and that minimum value is minus 2. Okay, right, children. Now there are two things out here. Now if you've observed in the language, at times they ask you what is the minimum value, what is the maximum value, or where is the minima and where is the maxima, or where is local minimum, where is. So as I told you, there are two things out here, x and y. When they say value, then they are looking for value of the function. They are looking for x, okay, sorry, for y, value of the function. And when they are saying point of maxima or minima, or what is maxima or minima, then you will answer for x. All right. So for this particular question, the language was only find the maximum and minimum value लिखा था clearly. Okay. So value लिखा था, तो अब आंसर करते समय आप value पर ही focus करोगे. You will just tell them what is the minimum value, maximum value, whatever the case is. At times in the question, they can also ask, where will you find maxima and minima? In that case, you'll have to tell the point. Okay. Like see in the previous question here, in the first question. ये तो हमारे as per our question, this was our solution, that we are observing this, that its minimum value is this, so straight away the answer, therefore the minimum value is 3. अगर वो पूछता आपसे where is the minima, so in that case you would put it like this, right? If the point is also required, then what are you going to do? See, you can observe from here that the minimum value this expression will take is going to be what? 0, because we are saying ये positive है, तो ये positive है, तो इसका minimum value possible is 0. And that is 0 when this expression 2x minus 1 is 0. And that would happen when x is 1 by 2. So point of minima क्या हो गया? Point of minima is 1 by 2. Minimum value is 3. Are you getting my point? Okay. So point of minima, minimum value. Point of maxima means x is equal to what के लिए function maximum होगा. और function की जो value of calculation होगा, that would be its maximum value. Okay. So you have to read the question carefully, whether they are asking for point or they are asking for value. Accordingly, you will give the answer, either x or y. Okay. Or fx. Getting it? Okay. So likewise, but for question number 1, it was only value, so I'm not focusing on the point, but I just had to tell you in case they ask you the value point also. Like for this, if they're asking you when will the value be minimum, so you would say value will be minimum when this expression will be 0, and that would happen at x is equal to minus 2 by 3. So point of minima हो गया minus 2 by 3 and minimum value होगी minus 2. Get that? Okay. All right. Now the third question given to you, expression was, I guess, stated like this only. Yes. That was minus of x minus 1 whole square minus 10. Now again, this is a square, so squares are always greater than equal to 0, but in our function it was negative. So if this is always positive, its negative will always be negative. Multiplying the inequality by a negative sign, the sign of inequality reverses. Last year you've studied that rule of inequality. So we will say if this quantity is positive, which has to be being a square, this quantity will always be negative. Adding 10 both the sides to match up with your function. So this whole expression, which is your fx, will always be smaller than equal to 10. तो ये इसका maximum limit आ गया. ये 10 से बड़ा नहीं हो सकता है, छोटा होते जाएगा. Okay, keep putting different values of x. This will go on minimizing. The whole function will minimize. So for this function, we have no minimum value, but its maximum value would be 10. You clear with that? Okay, next was your gx is x cube plus 1. Now for this, if we study it analytically, what will we understand? जैसे यहाँ हम squares का कह रहे थे positive होते हैं, अभी ये x cube का आप सोचो कि x is a real number, it's a positive real number. So any positive real number to power 3 will keep on exceeding. So as x tends to infinity means if you keep increasing x, x cube also goes on increasing. Okay, if you keep on decreasing x, so negative का cube negative होता है, तो ये भी और छोटा होता जाएगा, right? So x cube tends to infinity as x tends to infinity, minus x cube tends to minus infinity if x tends to minus infinity. Okay, for negative numbers, this will go on becoming as small as possible. Okay, so in either side of your number line, you observe that there is no limit for this function. Okay, जब यही बड़ा होता जाएगा उसमें +1 करोगे और बड़ा हो गया. Okay, बहुत छोटी चीज में एक +1 कर दिया, स्टिल वो बहुत छोटी रहेगी. Get the logic? Okay, so we would say this particular function will have neither maxima nor minima. Okay, means it will have no maximum value, no minimum value. All right. Okay, what have I? Acha, this was analytically what I explained you out here, or what I've written out here, the solution. This was analytical solution. Okay, by chance you get confused, so I was like, we can always, not only for this, for rest of the functions also that we've done above, for all of them you can also check and come to a conclusion by applying the derivative test that we have studied. फर्स्ट डेरिवेटिव टेस्ट वाज देयर, सेकंड डेरिवेटिव टेस्ट, दोनों टेस्ट से आप इनको क्रॉस चेक कर सकते हो, बट उससे ये बहुत लेंदी हो जाएगा. तो जब इसका सोल्यूशन हमें एनालिटिकली मिल रहा है, सो वी विल जस्ट गो फॉर द शॉर्ट सॉल्यूशंस एंड विच इज क्वाइट क्लियर. I don't think so there's any confusion in these arguments. Okay, so this is short as possible, but you could have cross checked it or done it by applying your rules also, first derivative rule or second derivative rule. Okay, so that is what I've mentioned here. Analytically, this is your logic. As x increases, x cube increases, this goes to minus infinity, this goes to minus infinity, so neither maxima nor minima. And if you want to do it by derivatives test, then derivative of gx would come out to be 3x square. Okay, then what do we say in that derivative? Whether we have a maxima or minima, our derivatives vanish. So this will be equated to 0, which will end up giving you x is equal to 0. So then I've done this by second order derivative test because the function was simple. So if 3x square was first order derivative, second derivative would become 6x. Now at this point हम check करते हैं कि second derivative positive है या negative. So if you put x is equal to 0 here, you end up getting 0, which is neither positive nor negative. If it would be positive, you would say minima. If it would be negative, you would say maxima. That is what the test said. I hope you've revised your test. Okay, but if you get neither positive nor negative, if you end up getting 0, then we say this is point of inflection, neither maxima nor minima. So यहाँ test से भी हमारा clear हो जा रहा है कि इसमें ना maxima है ना minima है. Analytically भी clear हो जा रहा है. Okay, anyhow you can give the argument. Okay. Yes, so those were the 4 parts for question number 1. Now, if I move on to question number 2. Okay, question number 2 says find the maximum and minimum values, if any, for the following functions given by. Okay, the question is similar. The type of functions are different. वहाँ पे polynomial functions थे, यहाँ पे functions में trigonometry आ रही है. Some more functions are coming in. Okay, so fx is equal to modulus of x plus 2 plus 1 minus 1. Okay children, whether it was a square, so the argument was it would be always positive. It's the same for modulus function. We know modulus function minimum value is 0, right? So minimum value of this would be 0, so the minimum value of the function would become minus 1. And where will we have that? If I ask you point of minima, इस question में फिर से पूछा नहीं है, but if in case it has been asked, then you would say minima, for the value to be minimum, this should be minimum. Okay, ये तो constant है, इससे तो कोई फर्क नहीं पड़ेगा. This minimum, then your function is minimum. All right. So, and when will this be minimum? This will be minimum when the minimum value of this is 0, I should say, because it's a positive quantity. Okay, and this will be 0 at x is equal to minus 2. So you would say point of minima is minus 2 and minimum value is minus 1. Okay, so that is how you have to go about these questions. Okay, so the second one also children see, but यहाँ पे negative sign है, so that you have to keep in mind. You would say this is always positive, so this will always be negative, right? So if this will always be negative, then it's like I had done there. The same way you have to give the argument. I haven't done it in writing. I thought you all will do it yourself. Like you would say x plus 1's modulus is always greater than equal to 0. So minus of this we know will always be smaller than 0. Okay. So minus of modulus of x plus 1 plus 3 will always be smaller than 3. That's how you'll do it. Okay. So then from here again it becomes clear that this will have this will go on decreasing as you keep x, but its maximum value is 3. Okay, so that is similar manner you can give the arguments here as well. Okay, now next is a trigonometric function. Now for trigonometric function also, अब जैसे हमें इनकी लिमिट पता थी that this is always positive, this will always be negative. For trigonometric function we know, see, we know sine cos ranges from -1 to 1. Your function had sine 2x plus 5, so adding 5 all the sides, so we've added 5. So this becomes your given function, that is your hx. Its range is coming from 4 to 6. Alright, so the given function ranges from 4 to 6. So यहीं से clearly दिख रहा है minimum value 4 है, maximum value 6 है. Okay, so that is how analytically you can straight away give the solution. Okay, next function is modulus of sine 4x plus 3. So again trigonometric function hai. So for that we would say, we know sine theta is always from -1 to 1. So sine theta plus 4, I've cut it short here, plus 3, sorry, it was. So adding 3 both all the sides. So if you add 3, then this becomes your function. So I've written fx function will be plus 3 minus 1 gives you 2 and 1 plus 3 gives you 4. तो जो ये वाला फंक्शन है इसका रेंज आ गया आपका फ्रॉम 2 to 4. ओके, एंड मॉडुलस था, तो अगर नेगेटिव आती वैल्यूज तो फिर हम थोड़ा और सोचते, बट दिस वाज मॉडुलस. मॉडुलस हैज टू बी पॉजिटिव, एंड जो इस फंक्शन का रेंज आया है 2 to 4 इज ऑलरेडी पॉजिटिव, सो वी नीड नॉट वरी मोर. वी कैन स्ट्रेट अवे गिव आवर कंक्लूजन फ्रॉम हियर दैट इट्स मिनिमम वैल्यू वुड बी 2 and maximum value would be 4. All right. Right, next function was given as hx is equal to x plus 1, and here interval is also mentioned, children. Okay, so this one, see, इसको वैसे analyze करना है, especially because interval is given is typical. So I've done this using derivative test. As I said, according to the function you'll have to decide कि हम किस approach से करें इसे. All right, so I've done it with derivative test. F, we've taken out the derivative of f hx is coming out to be 1, right, and it is not equal to 0. So हमारा first condition क्या होता है for maxima minima? We say that wherever maxima or minima is there, first derivative would be 0, and as the derivative out here is coming as 1, which can never be 0 for whatever be the value of x, because it's a constant function. So we would say this function will have neither maxima nor minima. Okay, आपको ऐसे सेकंड भी नहीं करने की थी जरूरत, बट स्टिल क्रॉस चेक फर्दर आउट दे. सेकंड डेरिवेटिव भी 0 आ गया है, तो ना पॉजिटिव आ रहा है ना नेगेटिव आ रहा है. ऑल्दो यू गेट योर कंक्लूजन फ्रॉम हियर ओनली. इफ द फर्स्ट डेरिवेटिव कैन नॉट बी 0, इट कैन नॉट हैव अ मैक्सिमा और minima. Okay, so likewise children, according to the function you'll have to see कि कौन सा मेथड किस वाले फंक्शन का कंक्लूजन करेक्ट एंड इजी दे रहा है. राइट